Good morning, everyone. Thank you for participation our online presentation. The author supposed to be present and present physically, but has absent due to his illness. I am Arnav Mukherjee from Khulna University, Bangladesh, in mathematics discipline. I have joined to you as co-author of the paper on behalf of the author for presenting our paper entitled image gradient based iris recognition for distantly acquired face images using distance classifier. I hope you will find these topics interesting and informative. Now I will briefly discuss the following topics sequentially: iris recognition, a brief literature review, problem statement and motivation, research methodology including gradient feature extraction, image classification and performance evaluation, then experimental setup and result analysis, finally outcome and conclusion and future scope of this work and reference. Now I would like to introduce iris recognition. Iris recognition is the process of identification and verification an individual person based on unique iris pattern. The iris is a thin circular diagram which lies between the lens and cornea of the human eye. It is only internal organ which is externally visible. Nowadays, they are used two type of iris recognition, namely controlled environment and uncontrolled environment. In controlled environment, the eye images is taken from the subject at a close distance. In uncontrolled environment, the eye images are taken from the subject at a long distance. Due to increasing the demand of automated human iris recognition, the existing systems are easy to apply for border crossing control system, but very difficult for high security surveillance in less constant environment. Now I discuss few uh, literature review about iris recognition. The first iris recognition was proposed by John Dogman. And Dogman, he the algorithm consists of loggable function and Hamming distance. Most of the existing iris recognition algorithm has been and use binary iris code based on wavelet filters and Hamming distance. But the limitation of this system is that it required high quality camera to capture the iris images, and its accuracy significantly decreased under non-ideal images with increasing number the images due to the sensitivity of iris localization to noise and different lighting condition. Now the previous attempts are mostly focused on web logger based wavelet transfer and gray images, but the local intensity or color density, pixel position of an image are not utilized the previous research, where iris texts are provide high randomness, including rings, rates, crypts, frosts, freckles, zigzag pattern, etc. To overcome this limitation and drawbacks, gradient-based feature extraction are extracted from low contrast and local changes, emulation changes that may be appeared in the iris images under less constant environment. The our proposed research methodology consists of two phase, training phase and test phase. Each phase consists of iris image preprocessing, feature extraction, classification, and finally recognition respectively. The diagram of the system are shown in the below figure. Now the first iris image preprocessing. Iris image preprocessing is the first step of this phase work, which consists of iris image enhancement, iris segmentation, and iris normalization. The work adapt a single scale Retina algorithm to enhance the image quality and reduce the effect or uncontrolled light source. And then random occur algorithm used to segment the iris region through a set of post pre-processing steps. Finally, Dogman Robert sheet model is follow to to normalize the segment iris by performing a map from Cartesian coordinate to polar coordinate due to having human iris variation. The next step is visa restriction. Uh, Kobashi and was to propose the gradient-based phasor restriction. Firstly, we extend the phasor descriptor as a root extension of shift and Hawk's phasor. The nth order autocorrelation functions of the gradient in local neighbor are defined as the following formulas. Here, the displacement vector are known as shifting vectors with respect to localization vector from the reference point of each pixel in the fixer, and m of p is the norm or magnitude of the pixel. The scalar function omega is used as weight of correlation which derive from the norm function. The practical formulation of first order and zero and first order auto correlation graph feature are defined as the following formulas. Here, the baseline parameters like gradient operator, orientation beans, special interval, weighted function, correlation order, special beans, block based normalization issue are tuned to extract gradient phasor. The gradient phasor extraction strategy are summarized in the following algorithm. The first step is gradient completion with the help of Robert derivative operator. The first order correlation, then the zero order correlation, and finally the first order correlation. Here, this taken only 4 times operating of multiplication. The next step is the Fisher normalization. All the Fisher vectors are normalizing using min max maximization technique to keep Fisher values within a similar scale without distorting difference in the range of values. Then the next step is to classification the iris images. In classification stage, we use distance based supervised machine learning classification technique. K nearest neighbor is used to predict a level of new sample based on majority voting. The choice of k nearest neighbor is very difficult because there is no optimal number of nearest neighbor for all distance matrix or feature descriptor or any other data set. Here we give provide a example to illustrate the effect of k nearest neighbor. Here, a new sample assigned to class A when the number of nearest neighbor is 3, and the new example assigned to class B when the number of nearest neighbor 7. So it is important to find out the optimal number of k nearest neighbor. There are several distant matrices are used in to train the classification model, but the most widely used Hamming and Euclidean distance are applied for most of the classification problem. But the classification performance depends on the matrices are used. For example, Euclidean distance matrix usefully for weight and length measurement. Uh, Hamming distance, city block distance is good distance measure for age, gender, and weight measurement. The following distance metrics are used to train the classification model and and recognize the accuracy of the iris recognition. Then next step is to evaluate the performance of our proposed algorithm. Several measurements are available for evaluate the performance of the classification techniques. In our study, we follow confusion matrix to provide to assess the performance of the classification technique. The confusion matrix is a matrix that show the actual and predicted class of the classification technique. The confusion matrix consists of true positive, false positive, true negative, false positive observation. Here, the performance of the classification will enhance with increasing the accuracy value of accuracy, precision, recall, and effort measurement. In our experiment, the experiment are carried out on Casio B4 database, which is publicly accessible largest database of human iris. The database consists of 2,567 eye images with 142 subject with including regular and irregular images most of the subject. Here the first row of the image show regular image, and the second row show the irregular image from the Cassiopeia database. Here we consider the only the first 14 subjects in our experiment, because is not considered in our experiment due to having regular images, and a total of 3041 images are randomly considered for each of the subject 50 to 140 to train the classification model. And similarly we selected 700 20 images are selected for testing the model. Now we analyze the performance of the classification technique as well as a descriptor with the help of receiver operating characteristics curve. The curve plot using all classification threshold as true, positive, false, and uh, false, positive, false. The performance are measurement with the top corner of the graph. The overall performance and outcomes are summarized in the following graphs. Initially, the first step is to compute gradient orientation. The gradient orientation are computed with the help of robot operator, one-dimensional operator, Sobel operator, and Pareto operator. Among them, the performance of robot operator is best and more competitive, and the performance of Pareto operator are least effective among them. Then the next step is to orientation beam. The orientation beam is spread over equally 0 to 118 known as unsigned gradient, and 0 to 130 30 degree known as assigned gradient. The performance of unsigned gradient is more effectively than the performance of signed gradient. Here, and the number of orientation beams are divided into 17 beams. The next step is a special interval. The correlation of gradient orientation depend on a special interval. Although a special interval performed with a special distance, but the performance of first order autocorrelation is based with including a special interval equal 4. The special interval depend on image quality and the performance of gradient operator. The next step is to special interval. We several special intervals are used to reduce the high dimensionality of the Gluck feature. The performance of 4 by 5 special beams are better, but the performance of 3 by 4 special beams is also good, but not good as the performance of special beams 4 by 5. Then we plot figure 11 plot the learning curve with correlation distance with using gradient feature descriptor. The boldface line for test score refers to the main score, and the shadow area around the curve represent the range of standard deviation. The slide blue and red color represent the test score and testing score. It is visible from the figure 11 that the curves are converging, are going to convergence at a good score, which suggests that the proposed model is not underfit. It also visible from the learning curve that the training score are always high through the iteration, and the test score are with increasing with the increasing mm, with the number of increasing training sample. From the learning curve, we can conclude that the performance of the model will be increase with the number of images. Finally, we goes to analysis our experimental result. From table 1 and figure 2, we see the performance of distance matrix. Among the distance matrix, correlation distance matrix performance the best and improve performance by around 2.25% than the most widely used Euclidean distance as compared to other distance metrics. The performance of Euclidean and Minkowski distance are same, but the performance is better for Euclidean distance. Then the performance of CB distance is less effective. In contrast, the performance of cosine distance and city block distance are well are equal same on table, but the performance of city block distance is better that are observed from the figure 10. And finally, standardized Euclidean distance and CB SIP distance performance with a high computational cost. To comparison the performance of our gradient feature descriptor with other gradient and histogram based descriptor like histogram is oriented histogram of oriented and shape invariant gradient local binary pattern and space time autocorrelation gradient, and finally Gluck with the other operator. Among the descriptor, our proposed gradient-based feature descriptor Gluck achieved the highest accuracy with 19.84 with reducing computational cost. The table show the comparison of our method with other competitive methods, but it is not feasible to compare our result with a previous result because most of the author use different strategy in classification, feature extraction, and preprocessing stage on different type of database with different distribution. For example, Pujara in example in reference 10 use used 18 acquired 84.44% result for 100 subject and 9.60 for 8 subject and obtain 8.6 for 20 subjects. And from the reference, we observe the performance of the descriptor decreases with the increasing number of uh, training subjects. Only the proposed method in reference 12 and 6 explained one distantly acquired large database Casio BU4, which is similar to our experiment. From the comparative study with other competitive method, we can demonstrate that The proposed framework is highly effective and robust for remote human iris recognition with compared to other gradient and distance-based approaches. Finally, we discuss about the conclusion of the proposed method uh, and discuss about future scope of this work. It can be observed from the experimental result that the chosen distance matrix influence the recognition outcome significantly, and the performance of distance matrix depends on the properties of Fisher vectors. The comparative study demonstrated that the correlation distance matrix may be employed instead of the most widely used Euclidean or Hamming distance for image piece matching classification problems and object recognition. The proposed frame provide a little improvement of k nearest neighbor classification technique against varying level of illumination, occlusion, or other noises. In future, Fisher fusion, selection, and fusion may be used to overcome the intra-class variation, which enhance the overall recognition performance of this iris recognition acquired using visible or near infrared emulation. Here we include some references that are used in our presentation. Thanks to all.
Thank you, Arnav, for your very nice presentation. Maybe now I will give the word to Professor Dilip, the chair of this session. Sorry for the beginning, but I'm waiting for the Professor Dilip, but we have some problems into the connection. Professor Dilip, can you open your micro and say something? Arnav, you can hear me, right?
Yes.
Okay. Professor Dilip? Anyone of the audience can make some question? If yes, you can. Professor, yeah? Professor Sanjay? Unmute your computer and make a question if you want. Professor Sanjay, unmute. Or ask a question in the chat if you want. Professor Sanjay. Maybe Arnab, I can make you a fast question. You have already implemented your work in a real case, in a real instance of the iris image or something like that, or you are until now testing your idea, your approach?
Hello, Dr. Dilip Singh, please unmute yourself.
Yeah, Professor Sanjay, I already hear, but I already made a question to Arnab. Just let me. Arnab, can you answer?
Yeah, but I can see that Dr. Dilip is unmuted, is muted. Who is chairing the session? Hello,
Professor Dilip.
Professor Dilip, please unmute your system.
Yeah. he says that he cannot see the presentation and can't hear anybody. I don't know the problem.
But he is sending to whom? Okay, then I'm handling the other one.
So you can make some questions to Arnab, or I can pass to the second presentation.
Okay, so the question is, can you summarize what are the major contribution of your work?
The major contribution of this work to provide a comparative study on distance matrix, and our experiment result show that the most widely used Euclidean distance can be replaced with correlation distance.
Wow,
This
good,
is the
good. But are you sure that similar type of findings has not been found for the in the past?
yes.
Means, hello, are you sure that the similar findings were not found in the past in the other experiment or in other setups? Hello.
Yes,
So if it is already found, then what is the novelty?
the novelty of this work is with the proposed method performance on noisy images, but the previous algorithm do not work well with low contrast images or local illumination changes. But our proposed gradient feature descriptor performing perfectly with these images and and provide a relative performance by accuracy than the other distance-based matrix classification techniques.
It's okay. Thank you so much. Uh, have a clap to you. It is online presentation. So, Philippe, go for the second presentation.
Thank you, Professor. The next presentation will be the blessing WEMB. I think that blessing are here. Blessing, you can unmute your computer and share your camera. The second paper will be the
Thank you
trustworthy
everyone
machine
for
learning approach
nice
for cyber
presentation.
attack detection, a review. Wembe, you can start when you want. Please, Arnab, stop your sharing to allow Wembe start. Thank you very much. Perfect, Wembe. You can
All
start.
right.
Sorry for the little bit delay, but we have time to. You can start.
All right. Good morning, everyone. My name is Gwembe Blessing, and I am here to present my conference paper titled "Is Trustworthy Machine Learning Approaches for Cyber Security Detection a Review." These are my presentation outline. As a matter of introduction, machine learning has seen considerable industrial use in recent years, with machine learning systems displaying superhuman ability in varieties of activities, including detecting malicious attacks. However, increased model complexity has often resulted in increased performance, making such systems black box techniques and generating ambiguity about how they function and how they draw conclusions, such as the decision logic of machine learning model. This inconsistency has made it difficult for machine learning techniques to be implemented in vital areas such as cybersecurity domain. Machine learning trustworthiness is a subdomain of machine learning that evaluates
Sorry,
techniques.
Wembe. Sorry for the stop. Your slides are not moving. Can you correct that part? I just see your first slide. Yeah, now are okay. Thank you.
Can you see my slide?
Yeah. Now it seems perfect. You can continue. Sorry.
Okay. Okay. Can you see my slide?
Yeah. Maybe go to
Okay.
the presentation mode and you can continue.
Okay. I guess you can see my slide. Okay. Machine learning trustworthiness is a subdomain of machine learning that evaluates machine learning in terms of fairness, discrimination, and accountability. In machine learning cybersecurity domain, fairness and accountability is very essential to demonstrate how trustworthy the system may detect malicious attacks. In cybersecurity, where so many decisions are critical to organization breakdown, a lack of interpretability in machine learning cybersecurity techniques might decrease trust in those systems. Integrating trustworthiness components such as explainability and interpretability will increase the acceptance of machine learning systems, especially in critical domains such as cybersecurity. The aim of this study is to provide an in-depth review and identification of existing trustworthy machine learning techniques for cyber attack detection. The research objectives include: one, to identify relevant articles; two, to execute eligibility criteria to select relevant articles; and finally, to interpret the result. In
Sorry,
order
Wembe.
to achieve objective
Wembe.
one,
Sorry.
extract.
Go, Wembe. Sorry. Go to the presentation mode. If not,
I
you just see the introduction part. Click on the bottom
Oh,
of
all
your
right.
computer. You have the presentation mode. Click on it, and it's more easy to us to follow.
All right.
On the bottom of PowerPoint, you have the presentation mode.
All right. All right.
Click on that, please.
Yeah, can you see my screen?
Just a moment. Yeah.
All right, this is the presentation view. Hope it is clear. Hello?
For now, I don't see the presentation mode. I just see the map out methodology, table 1. Now I can see that you are to the aim and objectives. But normally when you talk, I just see the same slide always. So when you pass, click on the button.
Can you, can you see the presentation mode?
Yeah. Now I can see.
Okay. Okay, let me continue from the research team.
Okay.
The aim of this study is to provide an in-depth review and identification of existing trustworthy machine learning techniques for malicious threat detection. The aim of this study was achieved with the following objectives. One, to identify relevant articles. Two, to execute eligibility criteria to select relevant articles. And finally, to interpret the result. In order to achieve this objective, we extracted articles from online database, scientific database, such as Semantic Scholar, IEEE, Willy Library, Scopus, Google Scholar, ACM, and so on. Then we also apply the search string as illustrated on the table. In order to achieve objective 2, we carry out eligibility criteria such as inclusion, exclusion, and quality criteria. These criteria were used to screen the required articles for this study. In order to achieve objective 3, the result was extracted from the selected article based on the eligibility criteria in objective 2. The results were also used to answer the formal research questions. So we apply the 7-step methodology workflow, which include the exploration of the research domain. Then we also implement the search criteria as earlier discussed in Objective 1. Then we store the retrieve information in CSV format. Then we execute the eligibility criteria in Objective 2. This criteria enable us to select relevant articles. Then we also expand the search query. This involve searching various digital libraries as earlier mentioned. Then we synthesize and analyze the article. Then finally we report the findings. So this is the formulated research question. Research question 1. What are the trustworthy machine learning techniques in cybersecurity domain? First, we identify and analyze existing trustworthy machine learning techniques in order for us to extract the trustworthy techniques in literature. Research question 2. What is the most efficient machine learning techniques to implement an explainable cybersecurity model? In order to achieve this, we identify and analyze different machine learning models in implementing trustworthy cybersecurity models. And finally, what are the impact of explainable machine learning in cybersecurity domain? The rationale behind this is to identify the impact of explainable machine learning techniques in cybersecurity domain. Accomplishment of Objective 1. In order to accomplish Objective 1, we utilize the aforementioned search criteria, which involved searching relevant literatures from scientific database such as Semantic Scholar, IEEE Explorer, Willy Library, and so on. The search result was retrieved in bibliographic reference CSV file, and a total of 760 articles were retrieved from the databases, and 40 articles were
Wembe, I lost your presentation. Now you
these
you
are based of the
Wembe, you cannot see your presentation.
which
Yeah,
can
now
you hear
okay,
me?
but we lost your presentation.
Can you hear me?
Sorry for this part. Let's wait for Wembe again. I think that Wembe are taking some bad connection. Let's see. Wembe, we lost your presentation.
Oh, can you hear me now?
And you are just seeing the same slide every time. So when you are talking, if you don't click on the presentation mode, we cannot see all slides. Try to share. Okay. Okay. Now I can see your presentation. You can continue, please. If not,
All right.
okay. Yeah. Yeah.
All right.
Go
So
on.
to accomplish Objective 1, we utilize the search string as earlier mentioned. Then we apply the search string to scientific databases such as Semantic Scholar, IEEE Explorer, Willy Library, Scopus, Google Scholar, ACM, and so on. The search result was retrieved in a bibliographical reference CSV file. Then a total of 760 articles were retrieved from the databases and 40 articles were retrieved from other sources. So this is the uh, screening of the selected articles. Over here, we have the initial search query, which consists of 760 articles. Then we apply the exclusion criteria. Then, after applying the exclusion criteria, 320 articles were removed. Then we also apply the exclusion criteria, which involves removing 281 articles. Then at the end of the day, we apply the final criteria, which involves quality evaluation. At the end of the day, 25 articles were retrieved, which was used for the analysis of this work. From objective 2, we can see that we have 2020 and 2019 has the highest publication, which is 7 respectively, while 2022 has 2 publications because the year was early when we started this special research. This shows that there is more interest in this research domain as time goes on. Then to achieve objective 3, we we evaluated the techniques, the explainable and machine learning cybersecurity techniques from the selected articles. First, we have the detection of intrusion detection system by Wang et al. The authors applied sharply addictive explainable and machine learning techniques. These techniques involve explaining like correlation between the different types of attacks, and their futures values were also provided by the global explainable technique. We also have Mahoba et al. The authors apply decision tree to detect intrusion detection system and enhance the trust management in intrusion detection systems. Then Marino et al. Also apply variable importance to estimate the statistical impact of each feature to generate explanation. The most relevant features in this work was used to interpret the reasons for misclassification, and it was also used to visualize the magnitude of qualifications. The result shows that the explanation generated by the model efficiently described the reason for classification, and the interpretation also matches the cybersecurity practitioner's knowledge. Then Barido et al. 2020 also utilized the rule-based learning explainable AI technique. The rule-based learning refers to any model that develops rules to describe the data from which it intends to learn. The simplistic conditional if-then rules or more complicated, a combination of simple rules may be used to create their knowledge. This ensures that cybersecurity practitioners we are able to explain the decision logic of the model in terms of detecting sophisticated attack. In order to accomplish objective 3, we provide answers to research question 2. The question to research question 2 is actually what are the most efficient machine learning to implement an explainable security model. The decision tree techniques outperform state-of-the-art techniques in terms of marginal improvement, interpretability, and transparency. The decision tree technique is also easy to evaluate and is computationally cheaper than other supervised learning techniques. Decision tree techniques also make decision using tree-like techniques and shows the probability of event occurrence. These techniques include a conditional control statement and provide a straightforward and interpretable decision rules. Unlike other supervised models, it allows developers and researchers to observe and interpret data logic. Decision tree algorithm makes decision using a tree, like I said before. Another advantage of decision tree is that it does not need to be normally distributed. However, there may be chance of overfitting if the model encounter noise. In other words, decision tree is the most efficient techniques in terms of explainability and trustworthiness in detecting malicious patterns. And this is due to the conditional control statement as that ensures a straightforward and interpretable rules. Then we also have the impact of explainable machine learning in ensuring trustworthy cybersecurity. Explainable machine learning plays a crucial role in ensuring trust management and understanding the impact of malicious data to detect any system infiltration. Explainable machine learning can also improve the robustness of cybersecurity infrastructures by highlighting possible adversaries that could alter the prediction. Cyber attacks can be easily interpreted if they are explained as rules, and simple interpretable rules such as if-then statement are also examples. Then explainable machine learning address cybersecurity transparency requirement, and there is some indication that can improve trustworthiness in cybersecurity domains. Explainable machine learning is necessary for providing fairness, trustworthiness, and reliable interpretation of the outcome of machine learning models in detecting malicious threats, conclusion, and future work. This study presented an in-depth review of existing explainable machine learning techniques and their impact in cybersecurity domain, as well as the most efficient machine learning techniques. The finding reveals that despite the accuracy and excellent performance of machine learning models in cybersecurity domain, their rising complexities are huge setback when users are involved, as these models can only provide an explanation or information about the logic for their outcome. Explainable machine learning will ensure ethical AI, trustworthiness, and also provide the logic behind the decisions of the model, unlike black box machine learning techniques. Interpretability in machine learning based cybersecurity model has become critical for increasing the confidence in machine learning based cybersecurity infrastructure. This study also reveals that the decision tree techniques outperform other state of the art machine learning models in terms of transparency and interpretability. In other words, decision tree techniques provide trustworthiness in explaining decision rules as well as providing decision logic or interpretability to the outcome of the model. Finally, this study suggests that incorporating explainability components into machine learning cybersecurity models will help uncover the root causes of defensive failures, making it easier for cybersecurity practitioners to enhance both cybersecurity infrastructures and development rather than just using model results, policy, and management. Thank you.
Thank you, Guembe, for
Thank
your very
you.
nice presentation. We have time for one question. Anyone in the audience can make a question to Guembe? Maybe Wembe, I will ask to you. This part is very interesting. For we start our research in our topic, but the next steps will be starting implementing some machine learning techniques, coding some approach. What do you think for the future?
For the future, we are currently working on an explainable machine learning techniques to detect AI-driven cyber attacks, which is part of my PhD thesis. And so far, so good. We've been able to develop a smart adult cybersecurity model to detect malicious attacks in the Nigeria financial domain.
Okay, okay. Thank you very much.
You're welcome.
Anyone, Professor Sanjay? I don't know if you want to say something. Maybe they are not here. We have some time because we are waiting for the two. Professor Sanjay, you want to say something to yours?
Hello.
Hello, Professor. Can you make some
Hello.
question? Can you make
Hello.
some? Can you make some question to Wembe?
Hello.
Yeah,
Yeah,
I
yeah.
can.
Yes, Blessing. So, can you conclude your observations in the what is your major outcome in this work?
Yeah, our major outcome is that our findings reveal that interpretability in machine learning based cybersecurity models has become critical for ensuring confidence in machine learning systems in cybersecurity domain, because cybersecurity domain is a very sensitive area where making decisions and providing high accuracy is not enough to justify the reason for machine learning outcome in detecting sophisticated attacks.
It's okay. Thank you. Any authors, any other audience want to ask questions, please ask. Otherwise, Felipe, go for the next presentation.
The next presentation will be Ruslan Sorano. Ruslan are here in the room virtually, but I think that Ruslan have problems in the connection. I cannot. So Webe, thank you very much for your presentation and good
Thank
luck
you, sir.
for the future. Okay,
Thank you, sir.
thank
Thank
you. So let's wait for the next presentation that will be presented by Ruslan Sorano, and the title is Comparing Effectiveness of Machine Learning Methods for Diagnosis of Deep Vein Thrombosis. But we are waiting for Ruslan. I think that Ruslan have some connection problems. Let's see if can return to the room. And I don't know if the last paper are here to present.
Hello, yes, I'm around.
Okay, you are presenting the last paper, right?
Yes, please.
Okay, maybe we can start with you if you are okay, because we don't have so much time. So Ruslan have some problems in the connection. We passed for the last paper. It's okay for you?
It's okay, it's fine.
Perfect, perfect. So you can share your presentation and start when you want. Okay. Thank you very much, Pichosa.
Okay, thank you.
Thank you.
Can you see my screen?
Yes, yes, yeah. Now I can see your presentation. Go to perfectly, perfect. You can start.
Okay. So, hello, my name is Babajide Johnson Odajude. I am one of the co-authors of this paper, empirical analysis of data sampling based ensemble methods in software defect prediction. So this is the outline of this presentation: the introduction, the methodology, experiment design, then the result, and then I move to the conclusion. Now, the idea behind software defect prediction is to deploy machine learning techniques to predict defects in the software system. And this is made possible through historical information, such as bug reports and source code edit logs that are often derived from software development process. And data from these software features, which include things like the source code complexity, where we have the line of code in Maccabi and Halstead, and software development history, software cohesion, coupling, all of these things uh, what from form the historical information from which all these models are developed. So data from these software features are used to build SDP models, that's software development prediction models. So sorry, software defect prediction models. And this can be developed using supervised learning or the unsupervised learning. So particularly the software attributes used to develop these software defect prediction models impact their efficacy. So it has an impact on how efficient these models are. And by default, these software attributes are often modeled and skewed, and which is what we refer to as the class imbalance. And it's been a problem that researchers have been investigating for over a decade now. But then, so to deal with the class imbalance problem, researchers have utilized several methodologies, and we have data sampling, the cost sensitive learning, and then the ensemble. And one thing to note is that independently, these strategies, these methodologies, if I will, have a positive influence on the deployed prediction algorithms in the SDP processes. So the objective of this study is to validate the effectiveness of the ensemble methods over conventional machine learning classifiers on data sampled data sets in software defect prediction. And the other would be to compare, the other was to compare the effectiveness of experimental data sampling methods on the studied ensemble. So for this study, we used these two ensemble methods, debugging and boosting methods. So for the data sampling approaches, we considered the popular oversampling and undersampling methods. And so for the oversampling methods, we considered smooth synthetic minority oversampling technique and the adaptive synthetic technique, and then the random oversampling. And for the undersampling, we considered the random undersampling and then the near miss. So for the ensemble methods, we considered bagging and boosting, just as I earlier said. For the prediction algorithms, we considered the decision tree and the naive Bayes. So this is how we went about it. We extracted 3 data sets from the NASA repository, which are KC3, PC1, and MW1. And as we can see from here, that the number of instances for KC3 is 194, and then we have the imbalance ratio of 4. The number of defective instances is 36, and the number of non-defective instances is 158. So this shows the imbalance we talked about when we talk about class imbalance problem. This again shows the imbalance we have in these data sets. And why this is a problem is that our major concern is to detect the defect. And the challenge has always been that most of these defective samples are not usually much, and then there is that imbalance, and so we need to look for methods, we need to adapt methods that will enable us to predict these defects more accurately. So the evaluation measures we used was AUC and MCC. So this is the experiment design. So the software defect dataset, we used the original dataset as is. Then we also sampled the dataset. We rebalanced the dataset using SMOTE, ROS, RUS, ADASIN, and near miss. After that process, we then bagged naive Bayes, boosted naive Bayes, and decision tree, the same process for boosted decision tree as well on all the data sets there. So on the original data set and on the rebalanced data set. And then we used k-fold cross validation where k equals to 10. And then we evaluated the model using the performance evaluation metrics, which I earlier showed, the MCC and the AUC. And then we compared the software defect prediction performance. So in the experiment, this is what we came about, the sampling and then the no sampling. So we observed that based on this study, we noticed that the sampling methods have an impact. Yeah, apart from the RUS, which is the random undersampling, the other sampling methods have an impact on the on imbalanced data set. So this is the case that it's not sampled. We didn't sample it, we didn't rebalance it. We have the naive Bayes. This is the AUC metric giving 0.662, and then we can see from the result that there is an impact that this rebalancing has on the data set. So we then also compared how about bagging and boosting using naive Bayes and decision tree respectively. We also noticed that there was a remarkable performance, just as we see here from the highlighted points. So all in all, the average um, AUC we obtained from this experiment was 0.995. And for the MCC, the same result was achieved, where this is the case of no sampling. And then we see again that there is an impact that sampling has on the data set. And same thing with the bagged and boosted data set. So this shows the comparison of what we obtained to when compared to what others have obtained. So in 2018, El Shogabi et al. They utilized stacking, which is another ensemble method. So they used naive Bayes, MLP, and J48. And the result there shows the AUC was 0.876 and then the MCC 0.443. Lee et al. In 2019, on this PC1 dataset, they used AdaBoost. Al-Sahidi and Khan used AdaBoost SVM, and this was the result. So the asterisk ones indicates the models from this study. So when we used the ROS boosted decision tree, what we got as the AUC was 0.999, and then for the MCC was 0.972. And similarly, for the Anderson boosted DT decision tree, we have the 0.991 and 0.905 AUC and MCC respectively. And for the SMOT, we have 0.985 and 0.909 AUC and MCC respectively. So from this study, we concluded that in most of the experimental scenarios, the studied data sampling method improved the prediction performances of the deployed ensemble naive Bayes and decision tree models. We also noted that when combining ensemble models with data sampling methods, the choice of data sampling method as well as the Bayes classifier is very, very essential if any significant result is to be achieved. And in terms of the effectiveness of the data sampling methods, we noticed that the oversampling approaches, in our case, the ROS, the SMOT, and the Hardison, they add greater and positive impact on the prediction models than their undersampling counterparts. And even between these undersampling techniques, we could say that near miss performed better than random undersampling. So this is our suggestion for future work, that further study on this hybrid technique should be carried out, however, utilizing other ensemble methods to investigate the data sampling method that best suits them, as well as the classification algorithms that works well with those ensemble methods. And these are a few of the references that we extracted from our work. Thank you.
Thank you very much for your very nice presentation. I think it was very clear. So in the audience, Professor Sanjay, you want to make some question?
Yes. So as usual, uh, can you conclude some of the major contributions or the your outcomes of the paper?
Sorry, Professor Sanjay, there was an hiccup.
I'm just asking you that try to summarize your major contributions in 1 or 2 lines.
Okay, so what we noticed is that when combining these ensemble methods, we should be very, very mindful of the data sampling methods, the choice of data sampling method, and we should also be mindful of the base classifier we use for the ensemble methods because they have an impact on how on the um, data set and they have an impact on the prediction model. I think that's
No,
the summary of.
yeah, but you know that all the authors means in this area we are just combining the methods, finding some results, comparing with others, and showing that okay, no, this and this what we are combining is better than others. So, what do you think about this point?
Sorry, Professor, I didn't hear you well.
What I'm saying that in these times, the normal tendency for this type of research is that they are combining the new methods, for example, at this time assembly learning algorithms, right? And then showing the results is performing better than the previous ones. So everybody is doing the same thing. So how can you say that this is the novelty of the work?
Yeah, so this is it's a work, it's a research in progress, and this is just part of a work that we still intend to further look into.
Okay, it's okay. It's okay. Thank you so much.
Thank you,
So,
Professor Sanjay.
okay, you are welcome.
Thank
So,
you.
is the Ruslan is present now?
No,
I
Professor.
can
He have
no.
problem. He have problems with the connection.
So okay, in the absence, maybe Ruslan promised me to present in the next session. So do not make him absent. Repay, right? And
Okay.
close this for the tea break because we are
Sorry, can I
running.
stop sharing? Sorry.
Yeah, please, please. Yes, yes, stop hearing. Yeah, you can
Okay,
do it.
thank you.
Thank you so much for your presentation.
Thank you,
Thank you.
Professor Sanjay.
Mhm.
So if you don't have more presentations, Professor Sanjay, I think that we can close this session.
Yes, yes, close the session and Ruslan will present the paper in the next session.
Okay.
In
Thank you
the
very
next.
much. Thank you
Thank
very
you.
much.
Okay. So see you at the tea.
Okay.
Okay. Bye bye.
Bye bye.
I also my battery. What is the battery of this system? I forget.
Okay.
Nobody is
So
there, right?
we can hear neither Dr. William,
What is your battery type?
Kumar, Dr. William is presenting
You expect in my session?
his presentation.
In another session.
So this is at least we can see your slides.
see me there? I'm there and I see you, Sanjay. Do you see me?
Present it. Make the presentation in 10 minutes, please. Be fast.
Maybe in the next one, because we have
Or maybe at 10:30 if you are not ready.
maybe, Professor, in the next session we have just 3 presenters, so I can put you as last presenter. It's okay?
Once again.
Yeah, please at 10:30 on the
10:30.
same link. On the same link.
Not the same
Okay.
link.
It is.
This section.
No, the section is 5I, SEPA A2.
A2.
SEPA A2. Check the program.
Yeah.
Next, search for the SEPA.
Well,
Search for the SEPA.
5I SEPA A2, I see that, but the chair says not you, but Dilip
Yes,
Singh.
it is Surya, but he is not connecting, so I'm sharing both.
Okay. Yeah, I can get to this one, but at what time do I start it? Or
At 10:30,
at the end?
10:30. Please be there at 10:30.
I can, if you want, I can start earlier.
No, not
All right.
earlier. It is a tea break. It is not time. Not start earlier. It is not
Okay, good,
beginning.
good. Sanjay, thank you. I'll be there.
One session is already there.
Good.
Bye-bye. Mert, are you hearing me?
Yes, I can hear you.
Perfect. So maybe let's wait some minutes for the share, and if you are okay, 10:30 we can start with your presentation. Okay?
Okay, of course.
Nice. Ruslan, we have problems now. You can hear me? Okay, perfect. Ruslan Sorano? Ruslan, are you hearing me?
Yes, can you hear me?
Perfect, perfect, very perfect. So Ruslan, we have problems in the before section, so maybe after the third presentation in that section, you can present, okay?
Okay, in the last, Sanjay asked me to do it first, so I'm not sure.
So yeah, you can
It's
do
same for me.
first. Yeah, if Mert Muzaglu, Mert, are you hearing me?
Yes, I can hear you.
So Ruslan Soran have a problem in the before section. Maybe you can start doing the presentation. It's
Of
no problem
course.
with you.
Yeah, of course, I can start my presentation.
So very
Oh,
nice.
thank you.
So
So, okay.
I had
Ruslan,
a,
maybe
yes.
you wait
Hi.
some minutes for the share,
Oh,
and after that we can start. Okay?
of
Yeah,
course.
I can try to start my
Yeah.
screen. Yeah.
Of course. Just to test. Perfect, guys.
So I'll share my screen first.
Let's see.
Yeah, I can see the presentation.
Cool. So shall I begin?
What, Mert?
Shall I begin?
Maybe Ruslan start. Okay.
Okay.
Who's sharing? Mert, are you sharing now or?
Maybe Mert, can you stop
Yeah.
sharing just to
Yes.
Ruslan Sorano start?
Yes.
Perfect.
Let me see. Do you see my slide?
Yeah. Very perfect. So Ruslan will present comparing effectiveness of machine learning methods for diagnosis of deep vein thrombosis. So Ruslan, if you want,
Do
you
I?
can start the presentation. Okay.
Yes, thanks. Sorry, Mert, for barging in. I'll try to go quicker.
No, of course.
Okay. Well, Felipe read the title, so just quick background and motivation. Deep vein thrombosis is one of the major causes of morbidity and mortality. It's when blood clot forms in the vein. Then it can block completely the vein, or it can dislodge and block the lung air supply, and that's almost immediate death. So it's one of the very serious diseases. And as of today, the clinical vital signs and symptoms are very unreliable. So there are three steps to diagnose. One is this integer questionnaire, which has both low sensitivity and specificity. The second is the dimer blood test, which is good for ruling out DVT. But the most conclusive is imaging, which is expensive and sometimes invasive. So it's not the first attempt to use machine learning for decision support in vein thrombosis diagnosis, but we tried to apply it to Norwegian healthcare system patient data. It's one of the first attempts, I believe. So we have two major questions. One is to see how the data set reacts to for us to try to predict the disease, because it's the first time this data set is being used for this purpose. And then how can we further improve existing diagnostic procedures by way of, for example, reaching maximum recall and see how high specificity can go. It's based on this study. It's a research in one of the regional Norwegian hospitals, and it's a patient who came with suspected deep vein thrombosis to emergency department. Data set originally had 1,653 patient records with 195 attributes and contained all kind of data, both numerical and categorical, lab test results, and of course diagnostic outcome. We created a framework for predicting DVT. Just briefly, I'll try to outline. We prepared the data set. On the whole data set, we did many rounds of stratified split cross-validation just to establish the baseline. And then the 4 best performing algorithms we used for hyperparameter tuning. That we used for training set. It's pretty standard procedure. Then after the best parameters were found, we applied permutation-based feature importance technique for further feature reduction to maximize accuracy. And then we adjusted the classification threshold to try to maximize the recall. First step, baseline performance. So as I mentioned before, we initialized with default parameters 20 models with different algorithms, used tenfold stratified split and cross-validation. If everything was repeated 5 times, so then we picked the best accuracy results. It was a 4 algorithm, all 4 from ensemble tree-based, random forest, gradient boosting, hist gradient boosting, and XGBoost. Then we applied hyperparameter search using grid search and tried to optimize the best parameters. After the best parameters were used, we also ran 5 rounds of tenfold stratified cross-validation to get the average result for both accuracy and standard deviation. At the next step, we inspected feature importance for our fitted estimators. We used model agnostic permutation technique. So we output the features according to their scores. And I'll just try to quickly go through images. D-dimer blood test showed the most importance, and that actually was the same with all 4. So what we see is the dimer blood test, which already is used for ruling out DVT, also is confirmed by our techniques that it's the most important in thrombosis diagnosis. But the next finding was that the top approximately 10 predictors, even though they were in different order from different algorithms, but it's the same 8 to 10 predictors, which are not as significant as D-dimer, but they also add some weight. So then after we ranged our features according to the importance, we try to refit the data set and revalidate using the subset from 1, 2, 3, and so on, the most important features to find the best result with a minimum amount of features. And then we saw that, for example, gradient boosting reached 91% accuracy using only 15 predictors from the original data set. And then at the next step, we did adjust the classification threshold because our data set is very imbalanced. It's about 1 to 4 proportion of positive and negative. So normal 0.4 threshold value is usually not expected to give good results. So we found that random forest responds the best to threshold tuning. So at 0.14 cutoff rate, we get perfect recall of 1.0 and specificity of about 0.4. And well, as I promised, I try to go quickly. I just look at this graph. Our final fine-tuned machine learning model is actually a combination of the traditional D-dimer ruling out system and machine learning approach. So if we only use a D-dimer, oh, I can hear echo. So. Yeah, thank you. Normal procedure is the D-dimer test has a cutoff value of 0.5. So all the patients which have 0.5 or less considered to be negative for D-dimer and excluded for further examination. Those who have 0.5 and more have to go through expensive ultrasound or CT or MRI examination, and that's usually a big waste of resources. So our proposed method was to use the so-called hybrid method. We use D-dimer to cut off the 100% negative patients, and then they apply machine learning model, which was fine-tuned random forest model, which helps us to eliminate even more patients from invasive or costly examination. So combined, about 40% will not have to go through CTI or the MRI, and the expenses will be much lower. And there are some numbers in percentage. So roughly we can say that about a quarter of patients who used to be sent to expensive examination will not have to do this. This is a big number for a local hospital. Okay, well, I thank you. I try to be very quick.
So Ruslan, thank you very much for your very nice presentation. You
thank you for letting me take North's time.
No problem. I write in the our assistant part that you are presenting in the next session, so don't worry about that.
Thank you.
Don't worry. So Mert, I don't know if you want to ask something to Ruslan.
No, just I want to thank you. Very good presentation, and you're very
Thanks
quick.
so much. It was a little stressful. I tried to present from my university, but they're so paranoid about safety issues. I couldn't use any way to have the video, but I had to drive home, breaking all the traffic rules.
Yes, Ruslan. Yeah. Can you hear me now? Congratulations for your presentation. Mark
Thank you,
from
Professor.
Meeting, right?
Say again?
Yeah, can you please tell me something about what are the major means outcomes of your work?
You mean the final findings or something?
Final findings. I'm not interested about the findings because findings is nothing, but I need to know what are the means outcomes, means what are the novelty, what are the novel results you got it, what has not been done earlier.
Yes. Yeah, I understand.
Outcomes, results are everywhere. You
Yes,
do
that's true.
anything, there is a result. But the result means what is the novelty of the work?
Well, in the last slide, but I'll start from the beginning. It's the first of the
In
kind.
2 lines, only 2 points. Please, only in 2 points or 3 points maximum. Not explanation.
Okay,
this is my achievement. This is my achievement. This is my achievement.
Yes, it's use of Norwegian patient data. That's new.
That is not yours.
This data set has not been used before, and as far as we know, Norwegian patient data was not used before in comparative machine learning technique study. And the second one is our proposed method of the hybrid deep vein thrombosis diagnosis, when we use the traditional blood test ruling out, and on top of it, we use our proposed model to eliminate even more patients. So it's a hybrid improved method of diagnosing of deep vein thrombosis.
Oh, thank you. I understand. This means you are improving the efficiency, you are improving the several parameters performance with this hybrid techniques. Am I right?
Yes, the thing is that as of today, there's no other, like no machine learning method definitely to predict deep vein thrombosis with 100% sensitivity. So we can only rule out the most amount of patients as possible, so they don't need to go through extra examination. So we increase that number. Instead of 28%,
It's okay.
it goes up to 40.
It's okay. Thank you so much. A big hand to Ruslan.
Thank you.
Okay. So please be present for the whole session. That is your punishment of this one, right?
Yes, I owe Mert at least that much.
Yes, okay. Please join to the whole day and encourage to the others. So next
Thank
presenter
you.
is the Marth, right? Marth from the Turkey.
Yes, I'm the
Yes.
next.
So you are working with the Professor Aktash, right?
Yeah, I'm
Mehmet.
working with Mehmet
Mehmet.
Estaktaş.
So,
Yeah, true.
nice to meet you, Marth, right? You are Turkish as
Nice
well,
to
right?
meet you.
I think so.
Yeah, I'm Turkish. Nice to meet you.
Okay, from where? In Istanbul?
Yeah,
I-
I'm living in Istanbul and working also in
Yeah,
Istanbul.
I spent 5 years in Turkey, right? I
Yeah.
love Turkey. Go ahead.
Thank you. So I'll just share my screen
Yes,
first.
share everything what you like.
Can you see it?
Yes, why not?
Okay, so shall I begin?
Yeah, can you start?
Okay, hello for everyone. I'm Mert Musaoğlu. I've been working as a data scientist at GTech Istanbul, Turkey. Today I'm going to present my proposed paper. The paper called On the Machine Learning Based Business Workflows Extracting Knowledge from the Large-Scale Graph Data. So here's my contents. I'll be mentioning about our motivation, proposed system, evaluation, conclusion parts respectively. So let's just jump in the motivation first. Websites receive many different actions on daily basis, like registration, sales, etc. With the huge amount of website traffic, it is hard to find and understand the customer conversions. Funnel analysis is a method to understand the customer conversions. It allows us to analyze the splits in the conversion paths. Funnel analysis not just tracks the conversions, it shows the conversion rates to changes the I'll just start again. It shows the conversion rate changes based on the user characteristics. In this study, we argues that clickstream data contains an essential signal for the predicting future user actions. We argue that if we can find the user that cannot reach the action stage, we can increase the conversion rate. So let's go into our proposed system. We propose a business process that can use the website navigation data to find which topic will be the next move in the people's navigation. You can see the system architecture here of the business process. For this study, we collect session-based navigation user data. In the regex module, as you can see here, each page URLs grouped and tagged according to which specific part of the customer journey. In this module B, sessionization, URLs are grouped by session ID, page ID, and time-based. In the data prep and cleansing module, the number of navigations is limited. The goal is here to get people's real browsing. Not this part removes the too much time on the navigation parts, basically. In the next section, targeting module, there is a label encoding made here by the selected targets. A 0 or 01 assignment is made here. The next step is preprocessing module. This module inserts the word embedding methods for the suitable models. In the training models, we train our algorithms. And the last module, the prediction module, you can predict the user next step in the prediction module. So let's dig in. This is our data flow diagram. As I mentioned, we just create our data sets for our machine learning and deep learning algorithms, then create our targets. After that, we use 8 different machine learning and 2 different deep learning models to predict the next step. For each different machine learning models, we use 4 different embedding methods. For the deep learning models, we use word-to-vec embedding methods, and we train grand total number of 34 different models for each predictions. So let's go to our evaluation parts. Since we develop a classification problem, we use accuracy and F1 score matrices. And here's our accuracy results. For the experimental study, you can see the 34 different models results here. It has been seen that character level TF-IDF embedding methods is more successful than the others in the datasets. Also, the tree-based algorithms works much better in this dataset. You can see the same results in F1 score metric also in here. So for the conclusion parts and the future works, with the proposed business process, the website navigation data have been used to find which topic will be the next.
Hello, good morning.
Sorry?
How are you?
Sorry?
Sorry, I've not been able to see the director for library. That's why I've not called you back or send a message to you.
You can continue. Sorry for that. I already moved Moses.
Okay, no problem. So we use different embedding methods and machine learning / deep learning algorithms to compare which will be the much successful. As a result, as I mentioned before, the character level TF-IDF methods is more successful in this data set, and the tree-based algorithms are much better. For the future studies, we aim to expand this study in other e-commerce websites. Also, we aim to increase the embedding methods we use in the future studies. So that will be all. Do you have any questions?
Thank you very much, Mert, for your very nice presentation.
Thank
Anyone
you.
in the audience wants to make some question to Mert? Please go on, open your micro, say something, or Professor.
It was a nice presentation, but any questions from the audience?
Thank you.
Ruslan, are you present? Ruslan?
Yes, I'm here.
Yes, please chair the session, ask the questions and arrange the session. That is the punishment for you, right? Ruslan?
Hello?
Yes, Ruslan. Please make him moderator. Ruslan is there. So just to, otherwise go to the next presenter.
I actually have no question. It was very nice to see the work you've done.
Thank you.
So it's very neat presented, and just good luck with your future work.
Good luck, you too.
Thank you.
Thank you.
So thank you very much, Mert, for your
Thank
very
you.
good luck for the future.
Thank you very much.
Thank you, Mert. So let's start to the next presentation. Just a moment. So the next presentations are entitled Augmented Intelligence, Multilingual Conversational Service for Smart Enterprise Management System. We are here the presenter, the speaker for this presentation. Moses? are you for the speaker? Or Aideni Manuel, is you the second speaker?
Adeni Emmanuel will be the one taking it.
What, Moses? Sorry?
Adeni Emmanuel will be the one taking it.
Okay. Unmute your speaker, your micro, Adeni.
Yes, he's the one doing it. Open your speaker, Adeni.
We can't hear you.
We can't hear you.
Please open your micro. Adeni, open your micro, please.
It's working on it.
Adeni, please.
Open your mic.
Open your
Open
micro.
your mic to speak.
We can't hear you. You have a button on the bottom of your page. Click on the micro.
Can you hear
Perfect.
me?
Perfect. Now perfect. So,
Okay.
Adeni, thank
Okay.
you to be here. I think that we are on time, so you can share your presentation and start the second paper, okay?
Okay.
Thank you very much. Good luck.
Thank you. So, can you see my screen now?
Not now.
Okay. Okay, please give me some minutes. It's trying to load.
I don't know.
You have a button to share your screen.
Okay, I'm doing that now.
Okay.
Okay. Can you see my screen now?
Yeah. You can start.
Okay, thank you.
You can start.
Okay.
Okay. Good luck.
Good morning, the moderator. My name is Adeni Abidemi Emmanuel. Um, I'll be presenting on a topic titled Augmented Intelligence Multilingual Conversational Service for Smart Enterprise Management Software, presented at the International Conference on Computational Science and its Application. And these are my co-author, also from the Department of Computer Sciences. These are my presentation outline, starting from the introduction to the references stage. Going further, I can say a conversational agents are gaining popularity in the corporate world as a way of increasing customer experience and economic competitiveness, just like the way we see like Alexa and the West. But though there are a lot of work that has been done in these aspects, however, we still need to improve on some aspects like a multilingual in which the conversational bot can switch from one language to another. And in order to do this, this study use what we call an augmented intelligence, which entails human and robots collaborating to minimize company value by appealing to their respective strengths. Now, this is an alternative paradigm of artificial intelligence that emphasizes AI assisting role in developing human skills, reflecting AI continually affects and enhancing human creativity. That is, artificial intelligence is being used in a wide range of our everyday tasks as we move in and move out to engage in our day-to-day activity. As we can see, most of the existing chatbot service only supports one language at a time, and And the training process is not usually user friendly. I think we have some multimedia companies like that use a conversational bot in which they are only a single language that can be represented at a time. That is, this study proposed a multilingual service that will deal with the limitation of the existing system by developing a system that will allow multiple languages on chatbot agents. Multilingual conversational search chatbot are software application that uses natural language.
Adeni, sorry, we have some problems in the audio. Can you check? Because we have some problems to hear you. It's not okay. Can you check again, please?
Emmanuel, we can hear you faintly. It's not clear enough. You need to speak up.
You already hear that the connection are bad, right? Let's wait some moments to check if Adeni can return and continue. Adeni? Let's wait just a few moments.
Good morning, everyone. I believe.
Now okay. Now okay. Okay. Because we lost the audio, we just hear some echo, but now I think that we are okay. You can continue, please. Okay?
Please continue. Ruslan, you can moderate. What's the problem?
Continue, Emmanuel.
Moses, what you say, please?
I said that you should continue, that we can. I don't know what he was speaking loudly the other time, so I don't know what happened again.
So you can present on his behalf if you are co-author.
Yes, I don't have his slide with me. That's the problem. It was one that was given the slides. Maybe I can call it and send it to me.
Yes. No, but it's not our problem that you don't have the slides. You are the co-author, you should have slides.
Yeah.
Just to ask him by phone.
Yes, that's what I want to ask.
And please, and also don't call or don't take any calls or don't call to anybody during the presentations. We are hearing a lot of calls. Director, do this, do this, do this. All the Nigerian authors, please. So, should we close this one? It is introduction first slide, right?
Yeah.
Adini, you can just ask him to give the slides to you.
Yeah.
Who is the presenting here? Adini or Moses?
Adeni is the presenter, but we have
Moses, Adini. What is our session now? Let me check the other one. Moses,
Yes,
Adini. So what's the problem? Could you able to solve it?
yes, we're about to solve it. Just give me some few minutes. I will probably try to share my screen if I.
Okay, we have only 3 papers in this one, right?
Okay, can I share my screen now? Hello, sir.
Yeah,
Yes,
yeah.
share, please.
Okay. I will.
Adini, what happened with you?
This is a.
You lost the connection.
Ruslan,
Yes, Sanjay.
are you available in the afternoon?
Say again?
Are you available in the afternoon?
Possible.
Are you available in the afternoon?
Yes, maybe.
No, but if yes, then I can allot you the papers. Means I can ask you to chair in the same room, but I can tell you the rooms if you
I
are
can
free.
I
Otherwise,
can
I can.
definitely help you if you need help.
Okay, no, it's okay. I need some hands, and you know I want to talk with you. So you in the same room, I present at 2:40.
Once again, is it next session at 2:40?
2:40, yes, 2:40. And in the same room, then again there is a 4:20.
Okay, so
Same
it's
room,
two. Is it 2 sessions or 2 presentations only?
yeah, 2 sessions. In fact, next incoming 2 of the SEPA.
Okay.
And other room I will handle by myself.
Good.
Because it is becoming hard. I gave a lot somebody and he has the same problem like you.
Yeah, yes, Sanjay, I'll help you.
Okay, this is the means it is the Dr. Ramesh is there, Darwath Ramesh, and 220. Then 4:20, it is in the same room. So in absence of now Moses.
Yes, I'm coming. Can you see my screen now?
You log
No,
into your
not
phone.
not now.
No. You log into your student portal.
We can see your screen, but we cannot see the slide.
Come ask your colleague.
Okay.
Okay, Ruslan, handle this presentation and see you at 2:40, right? 2:40 and
Can you see this
4:30.
slide?
Yes, Sanjay. Yes.
Okay, so I'm giving
Can we
you
see my slide now? Can you see my slide?
No. I just see
Head up.
your folder.
Can you see my slide?
No.
No. We can see this. We can only see the name of the slide. Just double click on the slide, open the slide, and do go to slide presentation.
Yes.
Before you launch the screen.
Okay.
We can only see the name.
Okay, I'm coming.
It is not on slide presentation.
Okay, I'll do that.
Go, Moses, because we don't have much time. So
yes, I know. Can you see it now?
No.
Should I share the slide from here?
Yes, slide is here and then we're moving it.
Okay. Just stop sharing your screen.
Okay.
Okay. So try to be fast.
Yes. We are presenting on Augmented Intelligence multilingual conversational service for smart enterprise management software. Our slide presentation.
Adeni, we don't listen to anything.
Yes, I can hear him as well.
Okay.
Okay, an augmented intelligence entails humans and robots collaborating to maximize company value by appealing to their respective strengths. Now, we are trying to look at an alternative paradigm of artificial intelligence that emphasizes AI assisting role in developing human skills, thereby reflecting AI's continual effect on human creativity. Now, most commonly used applications include navigation, which can forecast road congestion, real-time language transmission using camera, online platform, and chatbot, and among others. Now, multilingual conversation or chatbots are software applications that uses natural language to connect with individuals. And chatbot systems, on the other hand, are not just designed to replicate human communication. They are also beneficiary in a variety of industries like education, knowledge discovery, industry, and e-commerce. Now, as you can find out, chatbots have actually become increasingly important in a variety of businesses. And you can see which is being used in Apple Siri, Microsoft Cortana, and Cell Eyes. Google Assistant also uses it. Facebook Messenger bot also uses it. And then also Amazon's Alexa have all received similar interest. Nevertheless, developing bots with simulated cognitive capacity is still an area of research that we need to look on. Now, the physical world is transforming to being digitalized and makes everything connected. The development of mobile and network devices, along with modernization, has actually changed the way people interact with each other. And you can see that when you want to be able to interact with others, most of the time when you are busy, it's easier to use chatbot. As a result, various firms, including airlines, fashion labels, and insurance organizations, have begun to provide services to their clients using chat applications. A chatbot can identify the buyer's purpose and adjust products depending on the buyer's preference and taste. It can also help with the purchase, ordering, and delivery process. And that is why we're looking into this research. Now, the next one, the Augmented Intelligence multiple consultation system can be used to facilitate interaction between a business and its customer to enable a smart enterprise management system. When you have your customer and you can communicate with them, it really helps a lot in the business environment. The focus of this study is to enhance the chatbot agent with the augmented intelligence of things for multiple language interaction among the users with rules-based approach to achieve a smart enterprise management software. This study switched between English and French during the conversation with the client, and this will cause the conversation agent to find it enticing since it can concentrate and reduce the steps of the purchasing process to become a one-stop shopping platform. Now, we have seen a lot of work that has been done on this, like Racine et al. Investigated the chatbot-related API packages provided by Google, Amazon, and IBM, and suggests a chatbot system for student support. And then the study comparative analysis indicated that IBM Watson provided the most effective alternatives for assessing textual tone information in terms of attitude. However, the question and answer bank for all possible questions need to be inputted manually and assign them to intention in the chatbot experience expertise specification to respond correctly to user interaction. Uzain and others also focus on chatbot categorization and chatbot creation strategy, in which the author investigated chatbot categories of task-oriented and non-task-oriented chatbots. The authors investigated a variety of machine methodologies and then using neural network, sequence-to-sequence, natural language, and others. And then we also talk about Barberos and then Maboni et al. They also work on chatbot. Now, we also, from the list of the work of literature, it can be concluded that chatbot is an important aspect of enterprise management software development and many other related fields. In recent times, corporations have discovered uses for chatbots that goes beyond service delivery. Therefore, this study contributes to the body of knowledge by engaging the use of augmented intelligence to develop a multi-language conversion software for various organizations to achieve their purpose and then in their area of use. Now, the goal of this study is to assist users to interact with chatbots in their own language. It's going to be convenient for me to interact with chatbots not only in English, but in other languages like French, like my native language and all that. Understanding human communication is in various languages is very, very good. So identifying the language, translating the language, and applying to the language is very, very important. Now let's look at our methodologies. Now the top-down model was adopted in designing the multilingual chat system. The result of analysis was broken down to different components where the design started from the main component to the elementary component. The system is designed using the rule-based approach that makes it entitled for conversation training data. The training is categorized into three major subsystems, which are natural language data, stories, and rules. Next slide. Now, the training is categorized into three major subsystems, which are the natural language that we said before. Then we have the stories, and then we have the rules, and that's the structure of the training. So all these are used in order for us to now use the use case diagram of the chatbot system. Is to ask questions and then to give a response. And then it will check for the user's language. Once the user's language is known, then it will use that to be able to reply back to the user so that they will be able to respond to the same language that the user is using. If it is English, it will respond by English. If it is French, it will, but we have tried it with English and French. So it will also respond by French, depending on what you are trying to do. As you can see from the diagram representing the multilingual channel bus, we have the input message, and then the input we have the decoder of the intent, then we have the translated input. So the backend is the one that will do the major work. Once the user will not even know whether who is chatting with him. All he just sees that the person will chat with him in his own language, and that will be very comforting. That's very comforting for somebody that does not know French or does not know English. So we have to decide on what to do. So you just specify the language you want to use, and then it goes on. Next. Now, the implementation process. This program is designed to enable users to interact with chatbot in multiple languages as getting the device in their multiple choice. So the method of running the front end and backend is install the Piki, the NumPy, the Pandas using Python languages, and then to run the front end, we also require the npm install, and then we use the npm start. So once we have that, the program will be able to do that. Now, the implementation result is shown here, which is the interface that we use. Shows the simple chatbot system. This interaction with the chatbot takes place as it's using a rule-based approach. And then just to find out, system is designed to offer support for adverse drug reaction, blood pressure, or in hospital and pharmacies. So when you say something, it will respond to you. Now, for instance, if you say, how can I help you? Then it will probably reply to find me a pharmacy or thereabout. It will reply to you, and then you can say something like, "Hi, how are you? Is there any problem? How do you do?" He has been trained to be able to understand greetings like, "Hi there, how are you? Is anyone there? Hey, hello, hello, or good day." So he has been trained to be able to identify those ones as greeting, because we have different people greeting in different ways. Now, you can see that shows the interaction with the chatbot in French language. Users start the conversation with greetings like bonjour, and then comment and blue, and then from there, system will also respond by talking to them by recharging the hospital, and then the system replies to conversation with the same language, which is French, as you can see there. Next slide. Now, traditional chatbot technology offers a limitation of conducting a conversation only in a specific language. As you can see, most of the chatbot system is majorly in English language. The ability of chatbot to converse in another language is in great demand in order to build a separate chatbot for a global audience, or to switch language preference based on time or regions that you are working on. So all this results in multiplication of effort and time and cost. So multilingual chatbots are capable of conversing in multiple languages, not just translation. Gone are the days where multilingual meant translate and understand. So, in conclusion, augmented intelligence multilingual conversion service is a way to increase organization functioning efficiency and minimize expenses while offering clients comfort and significant operation. They enable firms to respond swiftly to a wide range of consumer inquiries and concerns while reducing the need for human intervention. This research developed a multilingual conversation-based software developed to converse with clients speaking languages, enhancing engagement on conversations. And which is very, very important for the industry of today, because you need to be able to converse with your customer in multi-language, because they are all over the world. And if you can be able to get this done, that is what we are trying to propose here. We've done it for French, and it's even possible for other languages. Next slide. Thank you. Thank you. These are our references, and thank you for listening.
Thank you, Moses. Thank you for your very nice presentation. And Adani, also, we have some problems, but I think that the presentation are very good. So I don't know if anyone in the audience, Professor Ruslan, I don't know if you want to ask something.
Well, if I hope somebody wants to ask more questions, but I've got a quick question. Is there some real life practical application as of today, or it's more proof of concept for now?
No, it's for real life application for today. That's why we're able to implement it using French for now. We know we have other languages, like we have Spanish, we have the other African languages that we are going to start to implement over time.
Good. Thank you. That's interesting research. I hope it will be in use in the nearest future.
So maybe I can ask you something because I also think that chatbot will be one of the future trends. So you think that chatbot needs to be implemented with specific control, or I can give to the chatbot unlimited skills or unlimited functionalities, or I need to control some skills? What do you think? Just a curiosity.
Yes, yes. Basically, what we'll need is that we need to train it to be able to get some more things depending on the organization. We all have different things that we are dealing with. So we can't just have a chatbot that will be able to attend to everybody. So we need to train it to our own satisfaction to be able to get to what we want it to do. But it's going to be very interesting. It's going to be able to do that.
Okay. Thank you.
I might have another question, Moses, if you
Okay.
don't mind.
No problem.
You know, in many countries, I'm sure in your country as well, there are
Yes.
several official languages and people are multilingual.
Yes.
And it's not uncommon that when you talk to each other, then you embed words from different languages in one sentence.
Yes.
Did you try to address that problem?
Well, we have not been able to look at that. We are just looking at the conversation from French and English. But
And
our
the
own
official.
language, the official language we have in Nigeria is actually three. And so it's difficult for us to be able to manipulate that. But we are going to look at that. It's going to be an interesting one so that we're able to work on the different languages and see what we can interject and see what we can remove from it. That would be a very good one.
Yeah, because it is an issue in many countries, like here in Norway. Many words from modern words from English don't exist in Norwegian language, so we insert English words in the middle of the sentence. And then I wonder how a chatbot will react if one sentence contains words from 2 or maybe 3 languages.
We have to see what we worked on that one. It's a challenge. We will work on it.
Good. Well, that's a new challenge for you.
Exactly.
Thank you so much for your
Thank you so much.
presentation.
Thank you so much, guys. Thank you so much.
Yes.
So, thank you guys for your nice presentation. Maybe for this section, we have another one paper that are presented by Sholani Lombo, Laid Oelad, and Absalam, but I think that they are not here. We are presenting the crime detection and analysis from social media message using machine learning and natural language processing technique. Maybe you can wait some minutes. If not, no one comes to the session, I think that we can continue for the keynote speaker that we have in a few moments on the program that you can saw in the website. Okay? Perfect. So guys, sorry, I will break a section in this section because I think that the third speaker will not come. So I will break this section, and I hope that you enjoy and also participate in the keynote speaker at 12. Okay. Thank you very much. Well, thank you, Professor Ruslan. Thank you, Moses and Adenai. Thank you, Professor Sanjay. Good luck for
Thank
your
you.
next.
Thank you so much. Bye-bye.
Bye-bye.
Thank you.
Thank you.